Hi, welcome back to Math with me, Marisol Lopez, your second grade math virtual content specialist. Think of me as your teacher's helper. In today's lesson, we will continue learning about measurement. This time, we are going to solve word problems involving measurement. We will also be introducing the number line. Are you ready to get started? Today, we will be answering the following question. How can you represent two-digit sums and differences using the ruler as a number line? Before we begin, I want to make sure that we know what a number line is. A number line is exactly what it sounds like. It's a line with numbers on it. Number lines usually start at 0. This number line stops at 20, but number lines can go on forever and ever. They can go up to thousands and even millions because numbers have no end. Did you know that you do not always need to use the whole number line? You can use a piece of the number line if you need to. I'll show you. Let's look at this number line. It's only showing us the numbers from 84 through 97. In other words, you only use the part that you need from this number line. And let's look at this ruler. What do the ruler and the number line have in common? Well, I am noticing that both the ruler and the number line begin at 0. The number line and the ruler have an equal number of spaces between the numbers, and the numbers are in order, and they increase by ones. It goes like this: 0, then 1 inch, 2 inch, 3 inches. There are little lines in between are part of an inch. The line in between the 0 and the 1 shows that you are half an inch away from 1 inch. This means that we can use number lines to help us solve word problems involving measurement. Let's look at an example from today's lesson. Let's read it together. Liza, Cecilia, and Dylan are playing soccer. Liza and Cecilia are 120 feet apart. Dylan is between them. If Dylan is standing the same distance from both girls, how many feet is Dylan from Liza? Draw a model, use any strategy to solve. How would you begin to solve a word problem like this? Well, I'll give you a hint. Distance means measurement. It means we are measuring how far one object or person is from another. This problem is also asking us to draw a model. In this case, we do not have a ruler that is 120 feet long, but we can draw a number line to help us. Let's solve this together. The first thing I'm going to do is go to the top and insert a line here. This is going to be the start of our number line. And I'm going to make this line a little bit thicker. Now, I'm going to make additional lines on this number line going down. But we know that the number line is 120 feet long. So the first number here, I am going to type 0. And then here I am going to type 120. Let me fix that. Okay, now I'm going to straighten this line out as well. All right, we have our number line from 0 to 120. Now we are going to start plugging in the information that we know from the word problem. So it says Liza and Cecilia are 120 feet apart, but Dylan is in between them. So let's draw another line for Dylan. And if something is in between, it's usually in the middle. So we don't know yet what number Dylan is standing on our number line. That's the part that we are trying to figure out. So I am going to put here a question mark. But above that, I think we should also put a text box here with the letter D inside representing Dylan. Now, if he's standing between Liza and Cecilia, it doesn't really say which side, if it's on the left or on the right. It just says that Dylan is standing in between them. So the question is, how many feet is Dylan away from Liza? Now, we can put Liza or Cecilia at either side of the number line. Put Liza over here. and Cecilia over here. The question is asking us how many feet is Dylan from Liza? So using what I know that half of 120 is 60. Because 60 plus 60 equals 120. We always use what we know in math to help us figure out what we don't know. So I'm going to plug in 60 right here. Dylan must be standing at 60 feet. The question is, how many feet is Dylan from Liza? I'm looking to my left where Liza is. How many jumps do we have to make to get from Liza to Dylan? Or how many feet apart are they? Well, I can write an equation to represent what's happening in the problem. 0 plus what is going to give me 60? I need to figure out, right, what's the difference, what's the distance between Liza and Dylan. If you have nothing and you add 60, 0 plus 60 equals 60. So that means between Liza and Dylan, there are 60 feet. That is the answer to the question. I can even write that in a sentence. Dylan is 60 feet away from Liza. Another way to figure that out is by making jumps backwards from Dylan to Liza. So let's say, for example, that I make jumps back of 10. So let me move this over here. I'm going to show you a different way. If I jump back 10 from 60, 50, it's easy for me to just copy the text box and change this number. And then I'm going to copy this line because I'm not at my goal. My goal is to get back to 0. Right? Now we're counting backwards by 10. So this number will be 40. I fast forwarded a bit. Another jump back of 10. And we land on 20. I'm going to move that away from the 30 a bit. And then I make another jump back of 10. And I land on 10. After that, we cannot make any more jumps of 10. We already made it to our goal, which was 0. So how many jumps of 10 did we have to make? How many jumps of 10 did we have to make to get back to 0? Well, let's see. I'm going to use my scribble tool. I made one jump of 10 backwards, and then I made another jump of 10 backwards, and I made another jump of 10 backwards. So I fast forwarded a bit, but I want you to see that I made 1, 2, 3, 4, 5, 6 jumps of 10 backwards, right? And 6 jumps of 10 also equals 60. So we solved this problem 2 different ways. And the subtraction equation for what we just did is 60 minus 60 equals 0, right? Because we made it back to 0. Now, if you have difficulty making something like this on Google Slides, that is okay. You can also do this on a sheet of paper. All right, let's look at another example from today's lesson. It says, look at the number line below. This was part of a whole meter strip, but it got cut at 49 and 66. These are our endpoints. What is the length of the pencil? We are trying to figure out what is the distance between 49 and 62. right? This number line or this part of the meter strip does not start from 0. So the way to figure that out is similar to what we did with the Dylan, Liza, and Cecilia problem. We can make jumps back on this number line and then count the number of jumps. And we can also represent that by showing a subtraction equation. Follow along with me. So the first jump that I just made backwards using the scribble tool, I started from the number 62 and I'm jumping back. And then what I'm going to do is edit copy and then paste the same jump so I don't have to keep drawing it over and over again. All right, so far I made 1, 2, 3, 4 jumps back, and this meter strip is actually going by jumps of 1, not jumps of 10 like we did last time. So again, every number line is different. Some number lines will do jumps of 1, some number lines will do jumps of 10. All right, I fast forwarded a bit and now we're making our last 2 jumps. There are those red helper lines that appear to make sure everything is nice and straight. Okay, so now we can count the number of jumps that we made from 62 to 49, and that should give us the measurement for this pencil. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We can answer the question by saying the pencil is 13 centimeters long. Now we know that it's in centimeters because at the top it says we're working with a meter strip. And then you can write the equation, the subtraction equation, 62 minus 13 equals 49 cm for centimeters. All right, wow, mathematician, you did an amazing job learning about number lines and using them to help you solve word problems with measurement. Don't forget to save your work to show it to your teacher. Keep up the great work, mathematician. Until next time, bye-bye.